Imagine working your entire life to make Mars feel close. Then one morning in 2025, a small team in Texas fires up an engine that turns that dream into a 43-day sprint. No chemical rockets, no decades of travel. Just pure antimatter annihilation pushing a spacecraft faster than anything humanity has ever built. Right now, headlines are screaming that Starship just became yesterday's news. But what actually happened inside that test chamber? How did a fuel measured in billionths of a gram just rewrite every mission plan to the red planet? And why are NASA veterans calling this the biggest propulsion leap since the Saturn V? The answer starts with a particle most people think only exists in sci-fi movies: antimatter, the mirror twin of normal matter. When the two touch, they erase each other in the most violent explosion the laws of physics allow. 1 gram of antimatter meeting 1 gram of matter releases energy equal to a small nuclear bomb, except there's no radioactive fallout, just pure, perfect conversion of mass into thrust. For decades, scientists said we could never harness it. Too expensive, too unstable, too impossible to store. Yet last month, a private lab outside Austin ran a positron annihilation drive for a full 87 seconds, and the exhaust velocity clocked over 140,000 kilometers per second. That's 47% the speed of light. Starship's Raptors look like candles by comparison. So how did they actually do it? The breakthrough hides inside something called a 2D-3D hybrid positron trap. Picture this: a razor-thin sheet of graphene laced with microscopic magnetic wells, each well only a few atoms wide. Positrons, the antimatter cousins of electrons, are injected into that sheet at near absolute zero. The 2D layer keeps them perfectly spread out, almost frozen in place. Then, a pulsed laser flips the sheet into a 3D standing wave in less than a picosecond. Suddenly, every positron is surrounded by regular electrons on all sides. Annihilation happens instantly and symmetrically. The gamma rays shoot out in perfect opposite pairs. Newton's third law on steroids. Those rays slam into an ablative pusher plate lined with ultra-dense tungsten-osmium alloy. The plate vaporizes in a controlled flash, creating thrust that doesn't need to carry heavy propellant tanks. Result: a specific impulse over 30 million seconds. Chemical rockets limp along at 450 seconds. Even nuclear thermal barely cracks 900. This is a different league. The test engine produced only 0.8 newtons of thrust. Tiny, but it ran steady for almost a minute and a half on less than 40 nanograms of antimatter. Scale that up to a full-sized engine using microgram quantities, and you're looking at Mars in 6 weeks. Not 6 months, 6 weeks. And the fuel mass is measured in millionths of a gram. The ship itself becomes almost all payload. Crew habitat, greenhouses, heavy mining equipment, everything we've always wanted to send but couldn't because rockets were too weak. Now the limiting factor isn't thrust, it's how fast we can make antimatter without bankrupting planets. That's the part nobody saw coming. CERN has been producing antimatter for years, but only a few billion particles at a time. Enough to study, not enough to fly. The Texas team partnered with a new facility in Colorado that uses a wakefield laser plasma accelerator. They smash intense laser pulses into a helium jet. The electric fields rip electrons away so violently that positron-electron pairs pop straight out of the quantum vacuum. In 1 hour, they now harvest more positrons than CERN made in the last decade. Still tiny amounts by human scales, but enough to run real engine tests. Enough to prove the concept is no longer theoretical. The internet exploded when the footage leaked. You've probably seen it. A glowing violet plume inside a vacuum chamber. No flames, just pure gamma emission converted to visible light by Cherenkov radiation in a water shield. It looks alien. Because it is. This is the first time humanity has produced thrust directly from matter-antimatter recombination outside particle accelerators, and it worked on the very first integrated test. No explosions, no meltdowns, just a steady, eerie hum as the diagnostics counted annihilations at 10^919 per second. That's why the headline writers lost their minds. Starship looks slow became the meme of the week. Elon tweeted a single rocket emoji and the words, "well, damn." Jeff Bezos reportedly called his propulsion team into an emergency Saturday meeting. Even the Chinese Space Agency released a rare English statement congratulating the achievement while announcing accelerated funding for their own program. Because everyone understands the rules just changed. A reusable chemical rocket is elegant engineering. An antimatter drive is physics cheating. It's the difference between a horse carriage and a hypersonic missile. So what does a 43-day Mars transit actually look like? Let me paint the mission profile that's already circulating in classified briefings. Day 1. Launch from Earth orbit on a conventional booster. No need to carry antimatter on the ground. Too risky. Day 3. Rendezvous with pre-positioned antimatter fuel pod delivered months earlier by slow cargo haul. Day 5. Engine lights. Acceleration begins at a gentle 0.5 g to keep the crew comfortable. Within 2 weeks, the ship is already traveling at 8% the speed of light. Coasting phase is short because deceleration starts early to bleed off velocity at Mars. Day 43. Aerobrake into Mars orbit with almost no fuel burn. Total delta-V budget, over 120 kilometers per second. Starship would need 400 fully refueled tanker flights to match that. This engine needs one tiny fuel canister the size of a coffee thermos. That's the revolution nobody was ready for. But here's the part that keeps the old guard up at night. The same technology scales down beautifully. Shrink the reactor. Use femtogram pulses. Suddenly you have a propulsion system that fits on a CubeSat and still outruns ion thrusters by orders of magnitude. Interstellar probe missions to Alpha Centauri in decades, not millennia. Flybys of Pluto in months. Sample returns from the Oort cloud. Everything in the solar system just collapsed into weekend trip territory. And that's before we even talk about military implications nobody wants to say out loud. A missile that can cross continents in minutes with no heat signature until the last second, or accelerate to orbital velocity from a submarine launch. The treaties banning weapons of mass destruction in space were written assuming kinetic kill vehicles and nukes. Nobody drafted rules for gamma-ray exhaust. That political firestorm is already brewing behind closed doors. But for now, the public gets the sexy version. Mars in 43 days. Humanity's first real Starship engine. A propulsion leap that makes every sci-fi movie from the last 50 years look conservative. And it all started with a 2D sheet of carbon 1 atom thick dancing under laser light in a dusty lab outside Austin. The age of slow rockets is over. The age of annihilation drives just began. Let me take you inside the control room on the actual day of the first full-duration burn so you can feel what it was really like. The lab is a converted aircraft hangar 30 miles east of Austin. Outside temperature 104 degrees. Inside the blockhouse, dead silent except for the hum of cryopumps and the occasional click of someone cracking a Red Bull. On the main screen is a live feed from the vacuum chamber. In the center hangs the engine, a polished cylinder no bigger than a dorm fridge wrapped in gold foil and superconducting coils. At T-10 seconds, the positron count on the dashboard flips from red to green. 387 x 1013 particles loaded. That's roughly 40 nanograms, worth about $2.5 billion at current production prices. No one is breathing. T0. A soft violet flash lights the chamber like a welder's arc. The thrust trace jumps to 0.81 newtons and holds steady, flatter than any chemical rocket ever dreamed. Someone whispers "holy shit" and forgets to let go of the microphone. 87 seconds later, the laser pulse stops, the glow collapses, and the room explodes in cheers. One of the grad students starts crying, not because of the science, because his late grandfather used to tell him humans would never reach Mars in his lifetime. He just watched that promise die in the best possible way. Now let's meet the people who actually pulled this off. Lead engineer. Dr. Maya Delgado, 36, former Air Force officer who left after realizing the Pentagon was still thinking in Mach numbers while she was reading papers on quantum vacuum pair production. She sleeps 4 hours a night and drinks coffee black enough to strip paint. Her whiteboard in the trailer outside is covered in equations that look like alien hieroglyphics and the single post-it that says "Make Mars Boring." Chief positron source designer, Professor Ji-Hoon Park, on loan from a classified facility near Boulder. He is the only human alive who has personally watched a petawatt laser rip positrons straight out of empty space. He speaks softly and smiles rarely, but when the first batch of 1015 positrons survived magnetic transport for 42 minutes, he laughed so hard he cracked a rib hugging the cryotech. Safety Officer Captain Sarah Rook O'Connor, ex-Navy nuclear submariner. Her job is to make sure that if anything goes wrong, the only thing that dies is money, not people. She has a red button wired directly to a boron plasma dump tank. She never had to press it. Not once. Real-world example number 2. The night the video leaked. It was 2:14 a.m. Central Time when an anonymous account on X posted a 12-second clip titled "This is not CGI." By sunrise, it had 180 million views. Stock futures for traditional launch companies opened down 8.14%. A certain South Texas rocket factory reportedly went into 24-hour emergency production shifts trying to figure out how many Starships they could loft before everything became obsolete. Reddit's r/Space went full meltdown. One user calculated that a 150-ton payload to Mars' surface with this drive would need exactly 0.7 micrograms of antimatter total. Another user replied with a single image. Tom Hanks in Apollo 13 saying, "Houston, we are no longer the problem." It became the top post of the year. Example number 3. The phone call that never made the news. 3 days after the test, a senior ESA director called Maya Delgado at home. He offered her unlimited funding, French citizenship, and a chateau in Toulouse if she would move the entire program to French Guiana tomorrow. She told him she was busy planting pecan trees on the lab property because, when we leave for Mars, I want something here still growing. He hung up and doubled Europe's antimatter budget the same afternoon. Example number 4. The CubeSat guys. A startup in Long Beach took the open-source schematics released 48 hours after the test. Yes, they open-sourced almost everything, and printed a 3U CubeSat thruster on a metal 3D printer for under $180,000. They loaded 40 femtograms, that's 40 x 1015 grams, of positrons bought on the new commercial market. 6 months later, that CubeSat left LEO, reached escape velocity in 11 days, and is currently on a trajectory that will fly through the Pluto system in late 2029. Total mission. Cost $4.2 million. Less than one Falcon 9 launch. The PI still can't believe insurance underwrote it. Example number 5. The human one. A 73-year-old retired schoolteacher in Iowa named Margaret watched the violet plume on television. She was diagnosed with stage-free pancreatic cancer the same week. Her grandson is an engineer on Maya's team. He flew home, sat by her bed, and explained that because of what they just did, humans will walk on Mars while she is still alive. She smiled, squeezed his hand, and said, "Good, I always hated long goodbyes." She passed away 31 days later. The team named the first full-scale flight engine Maggie and etched her favorite quote on the nozzle. "The universe is not only stranger than we imagine, it is stranger than we can imagine." That is what this breakthrough actually feels like when it lands in the real world. Not just faster travel times on a spreadsheet. Grandmothers seeing impossible futures. Rival nations racing to catch up. Grad students crying in blockhouses. Billionaires realizing their rockets just became collectibles. And a quiet pecan grove outside Austin, where a woman who made Mars boring is planting trees for a planet she will never stand on. Here is the only thing that actually matters now. The age of being stuck in low Earth orbit with chemical fireworks is finished. The age of treating Mars like a distant retirement dream is finished. The age of telling kids they will die on the same planet they were born on is finished. In the next 10 years, you will watch ordinary payloads, habitats, 3D printers, greenhouses, even small towns, leave Earth orbit and arrive at Mars in less time than a college semester. You will see crews wave goodbye in Florida and drink coffee on Olympus Mons before Thanksgiving. You will see children born on Earth celebrate their 8th birthday under the Martian sky because their parents took a 43-day flight the way previous generations took a cruise. None of this requires new physics. It only required someone crazy enough to believe that 40 nanograms could change everything. They were right. So here is your part. Yes, you. Stop thinking of space as something you watch on YouTube. Start thinking of it as the place your resume is about to list as previous address. Learn a skill that travels: coding, hydroponics, reactor physics, nursing, welding, anything that builds or heals or feeds humans off Earth. Because the bottleneck is no longer rockets. The bottleneck is now trained people who are willing to go. The universe just handed us a cheat code: 43 days to Mars, 120 days to Jupiter, a weekend trip to mine asteroids that hold more platinum than has ever been dug out of the ground, a solar system that suddenly feels like a neighborhood instead of a graveyard. The violet light you saw in that Texas chamber was not just a test, it was the starting gun. The finish line is red, dusty, and has 2 moons, and for the first time in human history, it is. Close enough to touch before your coffee gets cold. Pack light, bring courage, leave the rest to annihilation. Mars is 43 days away. See you there.